Welcome to here in the new lecture of the elementary combinatorics. So today before we move on to binomial theorem, we need to learn an important and interesting concept. We need to something called the Pascal's triangle. Wondering what is it? Come, let's see. Pascal's triangle is that it Pascal's triangle is the triangle made up of numbers. Is that it? No, of course. This move to it. Let's see what a Pascal's triangle actually looks like. A look something like this. Do you observe any pattern here? Here in this Pascal's triangle, each number is the sum of two numbers directly above it. Yes, notice that 2 is the sum of 1 and 1. This 6 is the sum of 5 and 1, and 21 is the sum of 6 and 15, so on. What else to be noticed? You also see that the starting and the ending numbers are always 1 at each row. Yes, all the numbers on the extreme left and all the numbers on the extreme right are all 1. In the Pascal's triangles, the rows numbers are starting from 0. This is the 0th row, this is the first one, then the second one, and so on. The third row is 1, 3, 3, 1. The fifth row is 1, 5, 10, 10, 5, 1, and so on. And you may be wondering why we need such a triangle. What to be even do with it? Don't worry, you will get to know that soon. So, first, tell me, tell you some real interesting facts about the Pascal's triangle. Take a look here at these two diagonals on either side. What are they? Oh, yes, they are the set of natural numbers. Can you find more patterns there? Check out these two diagonals. What could they possibly be? The numbers are 1, 3, 6, 10, 15, and so on. For each number, let's imagine the same number of circles. Let's arrange them like this. What do you see? We see that for each number we can form equilateral triangles. 3 can be arranged like this, 6 can be arranged like this, and so on. Such a set of numbers is called as a set of triangular numbers. Interesting? Right. Now, let me ask you the same question again. Do you notice any other pattern? It could be anything. I want to do observe each row. Let's see what happens when we add the numbers in each row of the Pascal's triangle. Try adding up the numbers in the second row. Adding up these numbers gives us 4. Now, can you try adding up the numbers in the third and fourth row individually? What numbers do you get? Yes, we get 8 and 16. Do you see a pattern here? 4, 8, 16, and so on. 4 can be written as 2 square, 8 is 2 raised to the power 3 and 16 is 2 raised to the power 4 and so on. How can we generalize this pattern? Yes, this is the sum of each row is equal to 2 raised to the power number of the row. You can check it out for any row. Take the 7th row for instance. What are the sum of these numbers? That is 128 and it is 2 raised to the power 7. So many patterns, right? But you may be wondering how will be used this Pascal's triangle in the binomial theorem, right? Let's see how. Can you tell me the formula of a plus b whole square? Yes, it is a square plus 2ab plus b square. Can you tell me what the powers of binomial here? You are right, it's 2. This power is also called the index of the binomial. Now, before we proceed further, we need to know what binomial coefficients are. Binomial coefficients are the coefficients of each term in the expansion of the binomial. Can you tell me what the binomial coefficients here? Can you tell me the binomial coefficients here? Yes, they are 1, 2, 1. Now, let's go back and see the Pascal's triangles. Can you tell me the numbers in the second row that are in the second row are the same as the with coefficients in the expansions with index 2. Now let's try it out with another expansion. Let's consider a plus b whole cube and we know its formula, right? What's that? Yes, that is a cube plus 3a square b plus 3ab square plus b cube. What are the coefficients here? Yes, that is 1, 3, 3, 1. Are the numbers are same as that of the third row of the Pascal's triangle? Oh yes, they are. So, what can we conclude from this? We can say that each row in a Pascal's triangle gives us the binomial coefficients for the expansion having any index, right? So clear what is the Pascal's triangles and where we use the Pascal's triangles and how can we use these Pascal triangles in our binomial theorem. So today's lecture is completed now. Thank you and in the next lecture we will study about the binomial theorem. Okay.